Good afternoon. This is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic flip-flop. Before getting into the topic flip-flop, let's recall about the latches. Latches are the level-sensitive devices which is capable of holding a single bit of information. The main drawback in case of latches is that it is not synchronized with the common clock pulses, and there is a race around condition that occurs in the latches, which means that when inputs are 1 and 1, there is a invalid output exists over there. So these drawbacks are overcome in case of the flip-flops. So the latches are the basic building block for flip-flops. And I'm going to discuss about why flip-flops are required and what is a SR flip-flop, working principle, truth table and characteristic equation of SR flip-flop, and finally about the real-time applications of flip-flop. Why do we need this flip-flop? As I discussed earlier, the main drawbacks of these latches are it is not synchronized with the common clock pulse, and it is a level sensitive and is highly susceptible to the noises. And these drawbacks leads to the development of a flip-flop. Flip-flops are edge trigger devices which are synchronized with the common clock pulse. So they are being employed in the computers, registers, counters, etc. What is this SR flip-flop? SR flip-flop is basically an SR latch, but it is synchronized with the clock pulse. So it has an input S and R, which is nothing but set and reset, and outputs are Q and Q bar. It is capable of storing a single bit of information, and it is a sequential circuit element, where latch is a asynchronous sequential circuit and this flip-flop is a synchronous sequential circuit. It can be a edge triggered or it can be a level triggered. And next is a working principle for this SR flip-flop. When the clock pulse is 0, there is no change in the output. Whatever data that is being stored previously will be getting as an output. When clock is equal to 1, it works like a SR latch only. When input is 1 and 0, the output will be 1. When input is 0 and 1, the output will be 0. When both the inputs are 0, it will be holding the previous data, and when inputs are 1 and 1, it is an invalid condition. And this is a truth table for SR flip-flop. When clock is 0, there is no change in it. And when the S is 0 and R is equal to 0, it holds the previous data. When S is equal to 1 and R is equal to 0, the output is 1, which is nothing but it is a set. When S is equal to 0 and R is equal to 1, the output is a 0, which is nothing but it is a reset. When both are 1s, then it is an invalid condition. And this is a logic diagram for this SR flip-flop. It is basically an SR latch combined with the AND gate. And we have a common clock pulse which is used to synchronize the entire flip-flop. It is an edge triggered logic diagram. It has an output Q and Q bar. Q1 plus 1 is a next state output. Q1 is a present state output. And next is a characteristic equation of this SR flip-flop, which is nothing but Q of next, which is nothing but next state output is equal to S plus R dash Q. Here Q is a present state output. So this equation is one which explains the memory property and it controls the entire transaction. And also the invalid state is being excluded over here. And finally, the applications of flip-flop in real world, and it is a basic for creating the registers and controller counters, etc. And it is mainly involved in the traffic light for controlling the traffic light sequences. And it is used for counting the time in case of digital clocks and timers. It is used to verify the passcodes in case of the digital door locks. And finally, it can be enabled in the communication equipment as well for data transfer. And next is a summary of what I have delivered so far. I have discussed about this flip-flop. Initially, what is the need for flip-flop, and finally I have discussed about the types of flip-flop, in which I have explained in depth about this SR flip-flop. I have discussed about this truth table, characteristic equations, and finally I have discussed about the applications of the flip-flop in general. And next is an activity. First one is a puzzle. From latch I evolve clock tie resolve, D my data, hold and resolve. What kind of flip-flop am I? Which is nothing but it is a D flip-flop which takes a single data as an input. And next is a word scramble. Unscramble, when we unscramble it, we'll be getting a count, which is nothing but it is a synchronous count. And next is an assessment, whose operation is more faster among the 4 options: combinational, sequential circuit, latch and flip-flop. Among this, the combinational circuit is more faster because it doesn't have any memory element. The truth table for SR flip-flop, how many valid entries are there? Totally we'll be having 3 valid entries, 0, 0, 0, 1 and 1, 0. When input is 1 and 1, it is an invalid state. And the references are textbook by Maurice Mano and Sally Wagner, which is a digital circuits and design and digital design. So that's all about the flip-flop. I have discussed about this SR flip-flop in depth, and finally I have discussed about the applications of flip-flop as well. Thank you.